Hello Earth, welcome to episode 22 of season 3 of Making Cell, a series of videos where I record myself designing and implementing a programming environment called Cell. If you're just tuning in for the first time, you can go to check out the project at github.com/autocode/cell. Link will be in the description. So yesterday I basically decided to start redoing the tests with a view of having pretty much everything tested through a single interface, which is cell.call, actually a single call. And a call is an interface. The outermost part of a call, any call, is an interface. And we even added the wipe call as well, which we didn't have before, which is a way of deleting. So what is their way of deleting stuff, actually, the main way. So we have that. The video unfortunately stopped recording yesterday. I think the disk is getting really full, so OBS stops recording the video when it does that. So I will just be keeping an eye every 5 minutes or so to see if it's still recording. I'm actually uploading some videos now to the cloud so I can delete them locally. Anyway, so this is working now, and if I do this, the tests are passing. Well, actually they stopped working at some moment here with the wiping, but I'm gonna fix that right now. Yeah, perfect. Yeah, actually it was an issue with the test, so I decided to wipe things here. So if I wipe serious, and if I get everything, then I'm going to get exactly what I'm getting here, which is party list 1 yan and 2 yip. Yeah, writing the test is amazing like this. I should have done it before. Like, look how much more readable, at least to me, right, is this compared to what would be an equivalent test. No, sorry, bottom. Like this stuff. And look at these tests that are more involved. Well, actually no, like these ones. It's a mess. So I think this is gonna work. So party list yan yip open 1, and this is exactly what I'm expecting. Why is it so slow? Because I'm doing get everything after serious was wiped. I'm also processing videos, that's why it's also slow. Yeah, this is wrong. And by the way, if I do this, I think I'm gonna get an error, right? Yeah, exactly. There's an issue there with the tests, which is correct. If I wipe party list 1 yan, nothing is gonna happen. And then if I get this, I forgot this tag, right? Interesting. I am removing this path. Do I want that behavior? Because the get and the wipe are not symmetrical there. But how would you delete 1? If you not allow it, if you do -1, then you cannot target the deletion of the last value. So this behavior is correct. But this one should work. Sorry, what's yeah, stag, not T. So which one is failing? Yeah. Interesting. That's also another no-op. So do I want to? It's a bit of a corner case because I'm taking the minimum of both. I think, I'm not super sure, and I have echoes of this in other libraries I wrote before, but if the length is larger in the message, basically in the prefix, you wouldn't delete it. I think I will do it like that. If path prefix length is longer than path. By the way, sorry, I'm changing. Here I'm always passing a path, so I'm not going to. I'm just going to do this. Oops, sorry about that. All right, we're back. So yeah, so let's do the annotated right away. In argument. No, I cannot do this because if the prefix is longer than the path, but if the path is shorter, then I don't need to do this. I can just do something like I would just do the prefix and then the path slice from 0 to the prefix length. Yeah. Yeah, that's correct. And honestly, we don't need this condition at all. We do not. If path is shorter than the prefix, we keep it. The prefix can only delete things that fully match it. If not, we take the compare the first n elements of the path with the prefix, where n is the length of the prefix, and if they are the same, we skip that path. Remove. All right. Yes, if I wipe everything, or actually we can just wipe the party list 1, and then we get an OK. Wipe the first member of the list. And then I will do I can just get the party list, right? I'm trusting that things are working. I would just get actually, let's improve the style a bit here. Just these two spaces are very nice. I would get a list with yip and open one. Get list after one element was wiped. It's actually an interesting case. Let me just do, because I'm not sure if I did that before, and then if I just do a general wipe, okay. At least after one element was wiped. Yeah, it would be yip. Actually, this is wrong in the test, but anyway, it is not working. If I'm wiping, yeah, yan, yip should be the first. Because I misspelled it, that's why. And this should not be there. Actually, here, let's just do add party. Yeah, this is a good corner case here. Open one. Like if you're wiping elements of the list, do you reorder the other ones or not? It's a very good question. I never had to do it before, but yeah, I would expect if you wipe elements of a hash, you don't. But if you wipe elements of a list, you would not want to leave them empty, right? It's an interesting question, huh? Because of course I could implement that as part of, well, not put, it would have to be wipe, really. But do I want to do that? Hey, you want to keep it like that. And also look at this, this is interesting. When I pass this expected one with Yanas 2, it's auto-filling that one there. It's like auto-filling the first element here, which I didn't even pass. Wow, tests really have a way to bring stuff up, eh? I guess the way I'm writing the tests, I guess it's just a habit after all these years. Okay, this is done. So now what? No, I have to do that in white. I think for now I have to do it. So how would you know what you're doing? When are you attacking a list? Could be the next to last, or you could even with the last one, right? Yeah, it would also be like that. Or there, it wouldn't be. Basically, it's the next to last or the last one, right? And how many gaps can you leave there in the thing? You will have to basically rerun through the whole thing and fill any gaps. Right? How would I know what to do it? Yeah, if I don't do this, it's gonna be a problem for a lot of people, and for me too. You will have to basically have another call to remove the empty spaces from the list. No, let's just do it now. Again, I forgot to update it yesterday. Okay. I love these people, by the way. They're always doing great stuff with the terminal. How do we do this? How do I detect what changed? Well, I will go through. Could you actually? This should be. It could be that any list that you have could be affected because you could be removing the last element of it. So it's not just the last element or the next to last. It could be any of them that you could be removing. Any of them. So anything that shares the prefix, any prefix. But even if the first one is a number, if the first element of the prefix is a number, then or you already could be everything. I guess to make it more efficient, you would be the position of the first list in the prefix would be from where you would count. Okay, then we would do it like this. It's amazing what tests do, huh? And not just tests, but the way you write them and the way you express them. Because testing is really using. Yeah, this is the way. No, before I put into this data space, first you remove and then you fill in the spaces. You basically do I will even do it with everything, right? This is going to be fast. Now I should do add one line of code to do that. So first list would be if b type is an integer, return k or 0, and then you would basically go through, list all the paths that you have and find gaps, right? So how would it work? Yeah, actually this optimization won't even last long. Let's just make a gap filler there, a general gap filler. It would be like this, because I had code with the +1, right, somewhere when I was validating, right? Validator. In the validator, do I actually validate non-consecutive ones? No, I don't even do that. Add a non-consecutive list. The validator doesn't do that. So it's new logic. You iterate the data space. You basically take common would be so basically when you start you would do something like current equals path, sure, but not always, right? You will be pushing to it. with path slice current length. No, it would be and then you would look at whatever happens next. Sorry about that. All right. Still recording? Yes. So, okay, you have the common one. How do you add more stuff here? I'm just going through, and how do I find the holes? So if you have let's say hash here, let's look at the data. So you have a party list. So in this one you would start right away with party list 2 and yip, and that would really be wrong, right? So you would look at the non-common parts, because you need to do two things. You need to find the errors and then fix them, right? Yeah, I guess you have to compare. Yeah, but how do you know when you're changing numbers or not? How do you really know? You cannot know that from Gauss, can you? I don't think so. You need to look at all the paths that you're removing. I think that's the key, right? Because you're not looking at the... I'm not sure if you can do this. So remind me what I want to do. So of empty spaces in lists after wipe, port rest of the test suites. I love how it is expanding fractally. So I port the rest of the test suite to 4tx unified cell.call interface with temp on temp upload, and we might add multiput at some point in this process. I think I need to be at peace with this, that things expand and it's still interesting and valuable. I just have this this part of me that just wants to rush through the process so I can get it out and people can use it and it can grow, but it has to be good, right? Let me just reset back to the beginning because it's so good already, first part. So, okay, let's just cheat a bit here. Let's see how much it picks it up. building cell. Issue at hand. How can I iterate through paths to find the missing list entries so I can reduce the decrement numbers of the following items? I'm thinking about, what am I thinking about? I'm thinking that I have to do it from the paths I deleted rather than doing a general pass after the fact, because I might not know what. Let's lose info by just trying to find gaps. Yeah, it's not bad. Something that's so long. I don't like the loop, but there's something there. So let's just look at the deleted stuff, right? So in this case, the wiped would be party list 1 yan, right? Yes. So I have to go and check party list 2, party list 3, party list 4, all of those. What? Why is it broken? Because I didn't put it. Okay, now, yeah. So I will basically go through, I find all the numbers there. So basically how to find things to the left of any number and make sure that they are patched. Yeah. and we do it right to left. Check prefixes. It's going to be a hash, right? It's faster. It would be go path. If type v is an integer, actually you can do if k plus 1 equals path length. We ignore the last element, yeah, because that's not in a list. We would do this, we would do gap prefixes. I would do path slice 0 to k, so without it. So for example, if it's 3, it would be 1, 2, 3 slice 0, 2, perfect. Set to true. So these are the prefixes I have to check. And then this would be, with string file, I can just do cell JS to text. Yeah. 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 Party list. Wait, why is it like that? No, I don't want it like that. Although it technically is like that, right? Yeah, it will be a safer presentation. Although I could also stringify it. Let's just be traditional for a bit. Yeah, that will also work. And I would start with the longest gap prefixes, right? Or it wouldn't matter. There would be an order. It would just tell me what to look for. I still think I don't need to do that, but let's just go with it for a sec. If I know that the party list could have gaps, I will look at the paths for party list. No, I absolutely don't need to look at that. I can just go through the whole thing, and anything that is a list, store it as a prefix, right? Yeah, that's it. Count. This prefix count. something like this, I think. Although this was a nice idea, I don't need to do it like that. I actually need this. But I have an issue with the nested lists there, because things are shifting. So how to do right to left first? The problem with coming from the top is that you see the left first, not the right, and that shifts everything around. Okay, if we were just doing the implementation for non-nested lists, where would it be? You would look at party list, it would be nothing, and then suddenly if you see party list 2, you know that's wrong because it's 0. So you set that to 1, and then you just set it to 1, and then you move to the next element. And if it was 3, you say the last element is 1, so just set it to 2. Okay, that would work. If you correct left to right, then you can actually look at it left to right. You correct and then you compare. That could work. Let it go. Path function vk. If it is the same thing, so we basically get current count will be list prefix count of JSON stringify path slice 0 to k or 1. If current count is less than path, than v, honestly, we can just do this, something like this. It will be, we can just do this. Path, okay, replace it in place. Current count, that's more explicit actually. We always return the path, right? Now we're just returning things one at a time, right? Return current count plus 1, and I initialize it to 0. And I need to update the current count, right? I do. Honestly, I could just do it like this. I don't need to do anything. I can just replace the elements in the path, right? Path k equals and then I will do list prefix count it will be path slice 0 to k. What did I do? It's quite interesting actually. This seems to have worked. Yeah, here what I need to do, honestly, is just do this. Yeah, it works. Now I have to test it with the or not. Brilliant, yeah. And if I would, yeah, this works. Yeah. I need to try nested lists, but the idea is that if you fix from the top on the left, you can tackle two simultaneous gaps at the same path level. Well, that costed us some time, but it's not so much code. Now for the tricky bits. We might have left gaps in the lists, so we fill them up. The logic is as follows: iterate all paths. For each path, iterate all elements for a number steps that are not the last element step of the path. Take the prefix without the and initialize account. When finding a gap, update the multiple gaps can be patched at the same time. Yeah. We ignore terminal steps or text or rightmost steps. If the count, you get the current count or initialize it to 0. If the current count is +1 is less than what the value is, step is, we update the step directly in the path. We update this prefix count entry. This concludes for filling up gaps in lists. We update the data space throughput. Return OK and close the function. Perfect. Not bad. All right, let's just try the nested list. Nested would be 1 list okay, there, setting a nested list, and then I just basically call wipe on nested one list 1, and then the result will be okay. I really like this. So I will basically do this, I'm getting everything, and I will basically get a nested 1 list 1 yip. It's not fully the nested test I wanted to do, but it's gonna be okay for now. I can always improve it. Yeah, what did I mess up? Yeah, the put is nested. The value is this. Oh, perfect. I think I'm gonna wrap it up here. I need to record all the way to the end. Thank you for watching.